Hello everyone, welcome to Code with Femi. In this video, we're going to be looking at Liskov substitution principle. This is the L in your solid principle. Just for quick context, this is actually solid principle is more about the principles you follow in writing your code in a way that you're writing quality code and you're writing a code in a much more structured way that can also help to ensure that when you want to maintain the code, it's easy for you to maintain it. And also when you need to add new features to it, it's actually very easy for you to add new features to it. I've actually done two videos on this already for to cover the single responsibility principle and as well as the open closed principle. In this one, we're going to be focusing on this Liskov substitution principle. So stay tuned. Liskov substitution principle actually states that a parent class can be replaced by a child class without affecting the program integrity. What this actually means is that, let's say for instance, you have a class that does a particular carries a particular function. You don't want a situation whereby maybe you need to do some extension on that actual class. You don't want it to change the existing class, the class you've already implemented. You don't want to change its behavior. You should just replace it. You should replace it in a way that it doesn't affect, also like causing bugs in the actual software. And we're going to be looking at that now. So let me just switch over to Visual Studio, and then let's just go through one basic example, which is let's call this class, let's use the fruit as an example. Like, let's say apple. Let's say you have a class called apple, and in your apple class, let's just remove that. In your apple class, we have different colors of apple, but the main one is red and green, right? That's the ones I've seen. So basically, let's just actually create a public let's say void. I mean, this method is not going to return anything to wherever it's been called. So public void, and then we say display color. And what this is going to do is going to console.write. We're gonna display the actual color of this apple to the screen, to the users. So let's make this red. So let's say this actual apple is red, right? This is actually a red apple. So anytime you call apple and say display color, it's gonna give you red. And let's just do that. Let's say apple is equals to new apple. Okay, and then we can say apple dot display color, right? So what this would do is this would actually display red, and let's actually just see that in action. But now I'm going to actually set up a problem so that we can actually see how Liskov substitution principle can help us to design our code in a way that we're not causing confusion. You're not writing code in a way that is quite confusing to your to whoever is even going to maintain the code, or a developer. But as you can see there, we have red, which is actually the color of our apple. Or let's even do this. Actually, let's be explicit and say apple color is red, right? So now this is the problem I want to create. Now let me now create another class. Let's create another class, but this class we're gonna make it orange. Let's create a new fruit and make this one called orange. Public, same story. We can actually copy the same method from here. just to save time. It's gonna be the same exact method because we wanna inherit that. Now let's say that this was the first class you actually implemented, and now you want to bring in a new class to do, to extend on it. But now the problem we have now is that this is orange, right? So this will be orange. Orange color is orange, right? Violet color is orange for this one. And this is the problem now. Let's say I want to inherit the same, the same apple, right? And I want to override this actual method now, which is this one. So we have to make it virtual because that's the keyword for you to say that this method you can override this method. Then in the actual child or derived class, you can actually now use override keyword here to say you're overriding that method. You can see if I undo this, you will see that there's actually a comment here to say that you can see there that you are, so that hides inherited member. To make the current member override that implementation, it says you add override keyword. See, so let's add override here. So that actually makes it able for us to override what is in apple. You can see there that there's apple, then we're overriding apple in orange. But now this is where the problem is. Let's say for instance now I want to instantiate orange instead of apple. But what happens is that we still actually, this is actually still an apple, it's still an apple class, and this is an apple object. But guess what, when I run this, the problem we're gonna run into is you're gonna see there that you're gonna get orange. But actually if you check the actual implementation that we have here, we're saying apple equals to new orange, and then you're saying apple.display color, which is not actually right. This actually breaks this Liskov substitution principle because apple is not an orange. It's never gonna be an orange. So just always bear that in mind, that when you are writing your code, ensure that when you are replacing the parent object, make sure that you are not changing the actual behavior of your parent object, because this is what we've done here. We've actually changed entirely the actual parent object, and the parent doesn't understand how, like apple is now printing out something else, and this is not this is something that we need, that Liskov helps us to solve. So where we can actually now refactor this to bring in a third class. This is where you can actually resolve the issue using Liskov substitution, whereby you create a parent class. We can call this parent class fruit, to say this is actually the parent class, which is fruit. Okay, and then fruit will make this an abstract, right? An abstract class, and this abstract class would actually have an abstract method void, and then we can say display color. Okay, so with that, what we've done now is we've created a parent, and then we can easily inherit fruit instead of we inheriting apple. Now apple as well can inherit from fruit, and this actually helps you to ensure that you have to change that from virtual now to override, because now you're overriding a parent method, which is the display color. And with this now you should be able to get like the right information here, because now fruit can be, so you can have a fruit which is fruit. This is a fruit, so a fruit can actually be an orange, or a fruit can also be let's just move down, and then we can reinstantiate the other class to say new apple. Okay, and then we say fruit dot display color, and if I run this, you would see now that you will get the actual color for each of those fruits that you've got. Now you can see if you read this through, fruit can actually be an orange and fruit can also be an apple. You see, so you just have to also understand in terms of how you group your classes together and how they relate to each other, and with that you'll be able to know how to structure your code properly, and to ensure that you're not causing confusion in your code, like you're not changing the behavior of your parent classes. Now you're introducing bugs, regression bugs into your software. You just have to ensure that you follow this principle. This is one of the confusing principle I've actually some people struggle with really understanding this actual principle, but it is very good to know how to switch from a parent class to a child class, and ensuring that the behavior of your parent class is not affected. I hope you guys really learned from this video, and I'll actually see you in my next video. Keep well.